Okay, 24. Again, another parallel to each other. I know the triangles are going to be similar. Again, if you want to know why they're similar, what was the main way of proving triangles similar? Main way. Angle, angle. You guys got vertical angles. And since these are parallel, you remember what like B and D were called? Alternate interior. So they're congruent. So I can put a 43 here. They're alternate interior. Can you find the one next to 152? What's the relationship with those? Those are 180 minus 152. Supplement. 180 minus 152. 28. What am I looking for? I'm just throwing up degree measures here. I guess we can find all of them, right? So if that's 28, that vertical angle there will be 180 minus 43 minus 28. That's 109. Vertical angle is also 109. This is going to be 28. And then I think I can answer the question from here. AC, let's see, which one is true? Angle D is not 28. Angle A is not 43. ACD we can find if we need to. BCE. All right, so it looks like they're asking for the angle that's supplementary to 109. All right, 180 minus 109, that angle is going to be 71. Both of them here. So that one's true. All good, Ellie? Jackson? 29. Take a look at 29, everyone. Okay, we got a little rhombus action going here. It's V, E, N, U. The diagonals intersect at S. VN is 12, EU is 16. Okay, here we go. What do you know about the diagonals of a rhombus? Got to know a couple properties here. I'm looking for two specific. Scott, one. They form right angles. They are perpendicular. That'll come into play. And one more. Molly?
Diagonals by 6.
Yep, so this one of VN of 12, 6 and 6. This one is 16, 8 and 8. And you're trying to find the perimeter. If I find one side, do I know them all? All sides congruent. How can I find that side? Pythagorean theorem. 6 squared plus 8 squared equals x squared. I got 36 and 64. I think that gives me 100. So x equals 10. And this Regents we're taking in 2 months. Look at, they threw 10 right up there. Pick me, pick me, pick me, right? Because you found x equals 10. But perimeter, so 10, 10, 10, 10. That's how we got your perimeter of 40. Diagonals bisect each other in a rhombus and they're perpendicular. So I can do Pythagorean theorem there. Okay, others? No other questions? We're good? Okay, so tomorrow you'll come in, get your Chromebooks out. If you want a sheet of paper, scrap paper to write anything on, feel free. Or if you want to write on your Chromebook, feel free to. Once the bell rings, I'll open it up and we'll get going. Okay, remember it's going to be 20 questions. Technically, you only need to answer 15, but you probably want to answer all of them because anything you answer above 15 gets you an extra bonus point. Last grade of the third quarter. Anything else last minute, or I'm going to shut this down? And like I said, I'm going to keep the answers open, so if you want to look at it tonight, fine. All good? All right, good luck tomorrow. All right, good luck tomorrow on that. I'm not going to waste the rest of the class today. Let's get to day 9 of your circles packet for me. This homework will be due Monday for us. Monday, all right? Because I want you to focus on the cumulative quiz for tomorrow. So this homework is due Monday. So if you finish early tomorrow, get out the homework, start working on it, and you have over the weekend to work on it too. So everyone good. Homework, tangent homework due Monday. Monday. All right? think we should be able to get through it with the time we have left here. Calcs out too. Let's get the calcs out. You're going to need those. All right, let me start off with a new vocabulary term. It's kind of convenient that we're doing this now. Tangents. I know a lot of you guys just think tangent as far as opposite over adjacent. This is totally different. Okay. Here's what a tangent is. In a circle, make a line, intersects the circle one spot only. All right, everyone see my diagram number one? See I have 3 lines going and see how they touch the circle in one spot? That's a tangent. Tangent lines. All right, touches the circle one spot. Go over my other diagram. Can you guys help me out? Explain to me why those aren't tangents on my other diagram. Why isn't PQ a tangent? It hits twice, so that's out. Why isn't RS a tangent? Okay, that's out. What about TU? That only hits once. What's the problem? Number 1, it's a radius. And number 2, is it a full line? No, it's got to be a line. And what's the problem with WV? It's not a line. If I extend it, how many times is it going to touch? Twice, right? So that's why all 4 of those aren't tangents. Touches the circle exactly once. Here's your first fact about a tangent. You guys could probably draw this off to the side here. Draw a circle O for me. Circle O, everybody. Circle O for me. Center's O. I need you to draw in your own tangent line right now. I don't care where it hits, but just draw a line in that hits the circle in one spot for me. Make it a line. Now what I'd like you to do is make a point where it intersects the circle and call that point P. Now these mathematicians are pretty clever when they come up with names of different things. That point P where it hits the circle, it's called the point of tangency. Pretty clever, huh? Point of tangency. That's your point where it hits the circle. So up above, everyone see point B, F, and C. Those are called points of tangency. That's where the line hits the circle. All right, point of tangency. Now what I'd like you to do in circle O is draw a radius with a condition though. Your radius has to be drawn to the point of tangency. You just can't draw, I don't want in any radius. Draw your radius to the point of tangency for me. And you have discovered your first fact about a tangent today. You draw a radius to the point of tangency. It is perpendicular to it. So what's it form? There you go. Only if it's drawn to the point of tangency, that radius. Okay? Only if it's drawn to the point of tangency. All right? All good? So if I draw a radius to the point of tangency, it forms right angles. All right, let's use it then. Let's use it. Help me find the value of x. Well, you know, that's 58. Anything you want to add on to your diagram now that you know this fact? Anything else you want to add to this diagram in number 1? 11, anything you want to add on to this?
Right.
Where?
Where the point of tangency meets the radius.
This is where I use this theorem right here. That's a right angle now. Can you find x pretty easily? I hope. At this point in the year, right? 8, how can I find x here?
90 plus 58 and like 180 minus.
Yeah, there's 180 degrees in a triangle. Minus 90, minus 58. We got that. Yep. And going back to my notes. 32. All right, there you go. So there's one way I can use it. Second way I can use it. Well, this looks nice. Anything you want to add on to this diagram that's going to help me out a lot? 3? Where? Yep. So CBA, everyone, is a right angle. How can I find x now? I got a right triangle, so why not use We've been using it all year. Why not keep using it? Pythagorean theorem. Ooh, not out of the woods that easy though. What are your A and B values here? Your two legs. What am I plugging in for A and B? Little help, 18. All right. Let's try again. 14. No, never here. Oh, 14. Yep, we're good on this class.
8 squared plus, no, 2 squared plus, oh no, it is 8 squared, never mind. 8 squared plus B squared equals C squared.
Oh, I got a B value though. All three sides are labeled. So 8's one leg. What's the other leg? X. How about the hypotenuse length? This is the hypotenuse right here.
Oh, it's 2. Or is it just 2?
I got this piece is X. This piece is 2. When I combine them, how do I write that? X plus 2 all squared. Everyone all right for A, B, and C? All right, the left side's no issue, right? 64 X squared. All right, don't embarrass me next year when you go to Algebra 2. You're 6 months away from going to Algebra 2. Actually, less now. 5 months away from going to Algebra 2. What is the deal here? That's not X squared plus 4. What do I need to do to figure out? I do X plus 2 times itself. X plus 2. We do a little double distribution FOIL, whatever you call it. All right, it's just not X squared plus 4. I got to multiply it twice. Combine your like terms. Should be able to combine a couple like terms there. When you have it all combined, let me know. 14 X plus 2 times X plus 2.
X squared plus 4.
That's it?
Oh, X squared plus 2X plus 4.
Okay, I got X squared here. What'd you get here? X times 2.
2X.
Then I go here, 2 times X.
2X.
What do I get in the middle?
4.
4X and then plus 4. Is everyone good now? What's your next move? What's your next move now? I got all that great looking stuff there. What's your next move? Got to solve for X, right? Zach, thought?
You have to move the 64 and the X squared over.
You want to move the X squared and the 64? I can do that. That's fine. You can always move stuff over. When I do move the X squared over, what's going to happen? See ya! They're gone, right? Does everyone agree? No matter if I move this X squared over to the left or this one over to the right, they're going to cancel. Everyone agrees? So I'm going to be left with 64 equals 4X plus 4. X squareds are going to cancel. Can we solve that now? I thought hopefully everyone's not having a heart attack anymore. Thought you were going to have to factor, huh? Wouldn't want to do that, right? In an above average class. When you're ready, let me know your X value here. Boom, 9, 15. Yep. So I can use it using Pythag too. All right, when the radius is drawn to the point of tangency. Anything? Because we got one more Pythag one. Oh, 2 more, sorry. Everyone see where you can put in the right angle here? We're all good. I'm not going to ask anybody there over at angle B again. Ooh, here we go. A squared B squared equals C squared, huh? This one's going to be a little tougher what A and B are, huh? And C? What do you think? A, B, and C here. Come on. Now we get challenging here. 1, George, you ready?
Yeah.
Darn right you are. Name the length of one leg.
X.
X, yep. BA is a leg. BC is a leg too, George, but I don't have anything written there, but I bet you could still find it. Think about what is BC in the circle?
The radius.
Okay.
Oh, 3.
Any radius in that circle is going to be 3, including BC. Everyone agree? 3? And then your last job here, George, how about that hypotenuse length?
10.
There you go. Everyone all right? How we got 3 is that other leg? It's a radius. Any radius are all the same. All radii congruent. So x squared plus 9 equals a hundo. Do I just make the 100 joke now? First time that's on some of your papers all year, huh? Too harsh? Too harsh? Sorry, get over it. Just wasn't funny because it hurts. Last step. I'd love for you to break that down, but unfortunately there is no perfect square that goes in the 91, so we're lucky. We're just going to leave it radical 91. There is no perfect square that goes in. As much as I'd love to have one go in it, nah. And the final one here. Looks like another a squared b squared equals c squared, but I'm going to make your life a little easier here because if we did this out the long way, we'd probably have to factor, and I know you probably want to avoid factoring at all costs. So I'm going to try to help you out here. First, tell me the 2 leg lengths here. What are the 2 leg lengths? 16. AB is a legs. Do we have 16? Okay. I'm just going to be talking to nobody. How about 8? What's 1 leg length? 8? What's up, Cal? So AB is a leg. How long is it?
12.
Okay. So CB, but I got nothing there, but it's a radius. The other radius is 9. All right, now I'm going to help you guys out here. I know most of you would probably say, all right, hypotenuse time, x plus 9 all squared, right? That's what most of you got. And I would expect you to do that. We go x plus 9 times x plus 9 off to the side. We're going to end up factoring. We don't want to do that if we don't have to. So here's my suggestion. Just figure out how long the hypotenuse is. Figure out how long CA is, and then any suggestion on how I can find x at the end? I'll figure out how long CA is by doing Pythag right now. How can you take that value and find x now? Don't overthink this. Subtract 9 from it, and you'll get x, right? So let's find the whole hypotenuse, subtract 9, and we're done, instead of having to factor and worry about it. So 144 and 81. What is that, 225? So how long is the whole hypotenuse? 15 units long. Now, okay, the whole thing's 15, so if I want to find x, 15 minus 9, I'll just get a 6 spot. All right. Whew. Guys all good? I'd say I'm sorry, but I wouldn't need it. Here we go. In fact, I love the misery in your face. That brings me warmth and joy. All right, let's just get right to it. You guys know one theorem already. If I draw the radius to the point of tangency, it's perpendicular. Now you're about to, instead of me giving you the second theorem, we're going to prove the second theorem. So here's my diagram up here. I want to try to show BA is congruent to BC. I go through this every darn time. That's not going to be true until what's congruent? The triangle. So I'm going to go CPCTC at the end. So can you get me the triangles congruent based on one of the 5 methods? So I can go CPCTC. Anything up here you know is already congruent. I'm trying to get these 2 triangles congruent right now. Anything you already know is congruent, whether it be facts from the past or a circle fact. Hello, Romeo.
A is congruent to C.
What do you mean A and C? Get them more.
OAB is congruent to OC.
So you're talking the angles.
Yes.
Okay, why?
Because of the tangency factor.
Okay, hold on. Whoa, whoa, time out. So you know based on our talk today, those are right angles, correct? Everybody else agree? Those are right angles? Yes? Okay, here's the thing though. The theorem doesn't say they're right angles. Everyone go back to the beginning of today's notes. I want you to actually read it here. The theorem doesn't say right angles are congruent. The theorem says these two lines are what? Perpendicular. So that's what I'm going to write step 2. Not that they're right angles. We can write that in a minute, but that their AO is perpendicular to AB. And on the other side, OC is perpendicular to CB. That's what the theorem says. It doesn't say you form right angles or they're congruent. It says they're perpendicular. And yes, this is going to be a long one. Ready? A radius drawn to, where's it drawn to, the radius? Point of tangency. Oh, look at this. Look at this spelling words here. Is perpendicular to, what's the radius perpendicular to? Not the point, but the tangent. Is perpendicular to the tangent. That is what that theorem's used for, is to show they're perpendicular. Now, can you tell me you have right angles? Can you tell, now that you know they're perpendicular, can you tell me you have right angles? Now I can, yes. Off a reason why we've used over and over again. So angle A and angle C are right angles. Anybody remember that reason we've used over and over, but probably not since a couple months ago? Yeah, it's like you guys riding a bike. Just get back on and you're good. Perpendicular lines form right angles. There you go. And you're not going to like how this proof ends, but oh well. What else is true? Zach?
Reflexive.
Oh, man, might as well throw the old BO, right? Somebody had to, Zach, right? Carter?
AO and OC are radiuses.
They're AO congruent to OC. That's something we learned in this unit. How do you got to start this one out, though? Because I'm not going to allow you to write all radii congruent, because that's false. All radii are not congruent. I could show you 2 circles where they're not congruent. In a circle, yeah. They are. Oh. Not feeling it, ladies and gentlemen. Not feeling this right now. Side angle side? Side angle side? Nah, those right angles aren't in between. Am I going to make up a 6 method that says side angle? Nope. Unless you want your wrist detached from your arm. We're not writing that down.
Wait.
Am I giving you an impossible one? No. Hi, Molly. Oh, everyone remember the old forgotten one? What's the H stand for? Hypotenuse, your reflexive side. What's the L stand for? Your radii can only be used in a? Got it. HL. This is HL right now. Do you remember, and this is great review, I can't go HL right on step 6, though. You got to tell me something first before you use HL. You remember, Scott? There you go. Boom. Look at this. Come on. We're hungry here. Triangle AOB and triangle COB are right triangles. Anybody remember that reason? Right triangles have? And I got them. Right triangles have right angles. Now you can go HL on me and CPCTC, so go ahead and finish that up. Woo! HL proof. Wow. Out of nowhere. No joke. So you're probably wondering, what fact did you just prove? Here's what you just proved. What are BA and BC? We have a name for them today. What are BA and BC? Okay, so here we go. Here's what you guys just showed me. Tangents drawn to. Notice where these two are both drawn to. Where? Point. No. AB and CB are both drawn to the same point, aren't they? So tangents drawn to the same, and I'm going to add an extra word in here. External. Where's that point got to be? Outside the circle. So tangents drawn to the same external point are what? What'd you just prove? They're always congruent. Yes. Now this can be a two-step proof. Yes, correct. This can be a two-step proof with this theorem. But hey, here's a way to remember it. And I never, ever want to see this in a reasons column. The other name for this theorem, the Party Hat Theorem. Okay, Party Hat Theorem. People refer to this as the Party Hat Theorem. If you guys don't get it, hi, I'm a Party Hat Theorem. Here we go. All right. Oh, it's also upside down. Okay, ice cream. Okay, shut it. It's a party hat for me. All good. All right, so two tangents drawn to the same point are always equal. Here's where you're going to use it. So I drew a triangle around a circle, but I want the perimeter of the triangle now. Somehow. Find the perimeter of the triangle given that info. Well, you guys know perimeters, all sides added up. What side do we already know? What's the length of one side already? 7, right? Now I got to figure out what the heck about the other two sides. Here's where this theorem comes into play, the Party Hat Theorem. Everyone see this tangent of 4? Isn't the tangent on the other side drawn to the same point? So how long's this tangent here? See how this theorem works. All right, this tangent here is 5. What's it on the other side? Also 5. Tangents drawn to the same point are congruent. So now I have 9. And then what about over here? What about this length right here, the missing one? 3, yeah. That's where this theorem comes into play. So now I have what, plus 8? So perimeter 16 and 8, 24 centimeters. Ooh, how about this number 2? Huh? Well, you think you're on easy street, right? You're like 9 plus 8 plus, yeah, about that. I got to get this side here, right? And don't think this cuts it in half. These sides aren't being cut in half. How can I get to that side? Where can I even start, Emma?
You can start on the. Hold on. You can start by looking at the 6 and then going to the other side and breaking that up into 6 and 3.
There you go. Everyone, hey, if that's 6, this tangent over here, 6. Whole thing's 9. Everyone, we're going good now. 3. Other tangent 3. That whole thing's 8. So what's my missing piece here? 5. And now I can fill it in. That's going to be 11. Questions? All right, these last two are for you and anybody who's around you that wants to work with you. This could be done anything we've done this unit. Don't just focus on tangents only. It could involve a tangent, could not. Anything we've done this unit. Let's go. it's fair game to solve for x. Anything we've done this unit. If you want to talk with somebody around you, go ahead. I'll give you a few minutes before we end class with going over these two. What could you add to this diagram in number 3? What can you add to this based on what we talked about today? 3, what could I add to this diagram? Yep. 1, 2, 3 out of 4 angles in a quadrilateral that I know, since it's a quadrilateral, all add to 10? 360. There you go. So I'm going to find x, take that 360 that all add up to, minus the 290s, and minus the 130 I was given. Oh boy, 50. 50? How about 4? Nothing from today. What's this and this? Those are radii, aren't they? And are they in the same circle? So what do I know about the two? What type of triangle is this? What's across from these congruent sides? Oh, congruent angles, yes. So if one's 50, the other's 50. And now x will be 180 minus those two 50s. Yes, indeed. We end up with 80 degrees. All righty. Again, this homework due Monday. Okay, due Monday. Get ready for cumulative review 3 tomorrow. Make sure those Chromebooks are charged for tomorrow.